Oliver, good. So we should be ready whenever time comes. Okay, everybody, it's 7 a.m. somewhere. This is the SIDROPS meeting at IETF112. Ideally, you're here for the fun. I'm Chris. There's Kayur and Natalie as well. I think we have Note well. Everyone should be able to definitely read that eye chart. All the slides should be downloadable in the meeting materials site. If there need to be updates, we can make those after the meeting's over, I suppose, at least to the archive. We have two things on the agenda plus some updates about drafts. I think we have the Jabber Scribe covered with the chat thing. I think we need somebody to take notes, somebody to volunteer. Ideally, the note-taking is in the note-taking tool even.
Yeah, Chris,
straightforward.
I can take notes, but I would love if our favorite note taker can keep an eye over my shoulder. George, would you?
George?
I'll give you my browser.
Okay.
If not, I can just go ahead.
Yeah.
I'll keep an eye, Natalie. This is Kayur.
Thanks, Kayur.
Okay. Oops. Oh, no speaker working for George. Oh, maybe we have to be able to select him or something. Okay. Anyway, this tool is very confusing. So for all the drafts that are currently in flight or waiting for review, I'm not going to go through every single one. A couple highlights. There's 3 pages of these. So the 6486 biz is off to the IESG. There's one other document I believe that was pushed forward to the IESG. Oh, just the LTA use cases, which I keep remembering as being recently pushed. Anyway, the rest of these are kind of waiting. There's a couple of working group last calls which either need to be issued. The has no identity. I think it had an update since our last conversation, so that needs to be make sure we're okay with it. Send it off to working group review. Or sorry, working group last call. There's a question about the 8210 biz. I think we were talking about sending that to working group last call in the last meeting. Then there was an update since then. I think if the authors can speak up on the list about it, we can decide where to go from there.
Sorry for jumping in, but for ASP documents, there will be at least one set of updates for both a profile and verification procedure before we can start speaking about working group last call.
Okay, cool. Then some ROV timing has a working group last call pending, which I think we'll decide upon at the end of the meeting time. And same for max length, RPA max length. I think unless anybody has any questions, I think we're basically okay with these. Going once, going twice. Is that a question? Okay. All right. So I think we're ready to do slides. I think the slide makers can present their screen. Provoke video, send video. Okay, let me stop sending my video. Okay. Oh, there's Ben.
I think you need to allow me to share my screen.
Yeah, let me see. Oh, there we go. All right. Again, super confusing how to use the video thing here.
How's the font size? View. Better?
Small size. Other people find that unsatisfactory.
Better?
Seems good.
Okay. So during the last meeting, in a couple of on a couple of topics, the fact that I had this kind of implementation for creating and signing and reading various RPKI objects came up a couple of times. So I thought it would be worthwhile talking a little bit, seeing as this call pretty much has everyone in the universe that's likely to care about it on it. So this is really just an opportunity to, tell everyone what it's about, and if they're interested, kind of, what it does and how they can contribute. So a little bit of background. It started out life really as a personal itch that I had to scratch around two problems. The first one was that it's always kind of bothered me that in order to read the objects that make up the RPKI, we either need to kind of crack out a browser and look at one of the various kind of tools, online tools that people have built over the years, or you have to really be a master of the OpenSSL CLI tool. And the name RPKI Mancer came out of the fact that I always felt like I was doing some sort of black magic whenever I was actually trying to read one of these objects using kind of the OpenSSL CMS and ASN1 command line options, which I can never remember, and I need to spend kind of an hour refreshing my memory before I can read anything. But that's not what initiated actually writing the thing. What actually initiated writing the thing is I was part of one of the authors on the signed checklists draft, and we were going through a few iterations of the ASN1 module, and I wanted, because I'd never really done anything hands-on with ASN1 before, I wanted some sort of tool to add to a kind of a CI pipeline that would allow me to, allow me to know at commit time whether I'd broken anything in the syntax and whether the syntax that I was writing was resulting in an object that could actually be written out to the disk. And first of all, so Yob had previously created a demo object from the first version of the ASN1 module that was written for the draft. And my initial attempt was basically trying to script what he did. And after a few minutes of him explaining what he did and how he did it to me, I gave up because there was lots of manual twiddling of text files and lots of different stages which failed in cryptic ways if you got it even slightly wrong. And most importantly, even with all of those steps, couldn't deal with the untouched ASN1 module with its imports and so forth that was going to appear in the draft. And what I wanted to do is make sure that the one that was actually in the draft was valid. So the second thing I tried to do is I started trawling around some open source RP implementations and discovered, to my slight surprise, that nobody actually uses the ASN1 modules that are published in the RFCs to generate any code, or at least most don't do it at all. I believe that Fort does do it a bit, but with some fairly heavily patched ASM1 modules in order to get things to work. And so then I tried to go out and find a relatively widely used ASM1-C compiler called ASM1C, and it just couldn't cope with any of the dependencies. It didn't like the X509 modules, it didn't like the CMS modules, it didn't like really any of the modules that get used in the pyramid on top of which RPKI signed objects are built. So that all rather came to nothing, and so I decided that I either needed to not have such a tool or I needed to write it myself. So the first thing that I needed to do, because I wasn't really in the market for writing an ASM1 compiler from scratch, because I didn't really need, a particularly performant ASM1 compiler. What I needed was something fairly vanilla flavored, but which was out of the box going to work with some of the slightly more outlandish syntax constructions that you find in modules such as 5912 and stuff like that. So I did a lot of searching. There's quite a lot of different ASM1 implementations out there. Most of them are not what I would call an ASM1 compiler. They don't generate code. They expect you to hand write data structures, and what they'll give you for free is things like a DER encoder and decoder. But finally, I came across this library called PyCrate, which I'd never come across before, and it has some fairly ugly warts, but it was very, very feature complete. And so I decided that although I'd started this off not really wanting to write this thing in Python, PyCrate is a ASM1 to Python compiler, and so it seemed to be the only way forward. And that's what gets used under the hood for the ASM1 compilation part of this. And so with that in hand, I began kind of scratching around and trying to build a library that would meet kind of two objectives. I wanted to be in a position where, given only a ASM1 module with a content type instance definition and a very, very simple class implementation corresponding to a particular object, I wanted to be able to instantiate any arbitrary new RPKI signed object with just those two things, and try and keep the boilerplate to an absolute minimum. And I think mostly I've succeeded in doing those. Because Python's an interpreted language, it kind of works. Trying to do code generation in Python is a bit weird. You don't have a discrete compile time step like you have in C or C++ or Rust or Go even, where you've got an opportunity to take some sort of external data and generate code from it before a compile step. And so a lot of the work that I did was getting ASM1 modules to be discoverable and compilable at runtime, which makes the whole thing much, much easier to use as a library user and as a CLI user. The downside is it makes the tool terrifically slow. So this is not something that should be used in performance-sensitive situations. The other thing that it does, which I believe is unique as far as I've been able to find out there, I'm sure someone will correct me, is I wanted to be able to auto-discover the different instance definitions that exist in any of the modules that I've compiled of content type. So I know what can validly appear in a CMS data structure at runtime. And that also works, which is, it requires some fairly obscure and fairly recent Python features. And so unfortunately, RPKI answer only works on Python 3.8 and above as a result of that. But I think it's worth it because that allows us to keep boilerplate to an absolute minimum, and it also places the onus of correctness much more strongly on the side of what's in the ASM1 module that you're looking at rather than what's in the Python code that the implementer is writing. So it includes implementations of TA, CA, and end entity resource certificates. It can also write TAL files. It's in the base package, in the kind of the main RPKI package, there are implementations for manifests, ROAs, and Ghostbuster records. And it ships with a fairly simple but quite extensible CLI tool, which has two subcommands. RPKI and conjure creates a kind of a local publication point on disk, and everything kind of ships with default. So you can run literally just that command and get a whole, get a TA with its publication point and manifest and CRL, and then a subordinate CA and a bunch of stuff under that. And that makes for very quick and easy object generation if you're just trying to spin up a quick prototype to see if someone else can read it. I'm sorry, I've gone way too far. And then the second part of it is the perceive command, which is a decoder and data dumper, which just dumps signed objects to standard out, and it can dump it out in ASM1 value syntax. It can dump it in JSON. It's possible to provide methods for custom formats, like there's one that I've written for the rower object to allow you to actually look at the IP addresses as IP addresses rather than the weird kind of DER bit strings that are used in the actual encoding. And it's got a plugin architecture that borrows quite heavily from the Python setup tools way of declaring plugins, which allows plugins to declare the ASM1 modules that they ship with, the signed objects that they can create, and also extensions to the RPKI and conjure subcommand. And there are existing plugins, both of which I've written, for the RSC object and for the ASPA object. And there's a working branch for the ASPA object for the most recent proposed change to the profile that's been discussed recently on the list, and which has, I believe, been implemented in the most recent version of Krill. So that should interop, barring a couple of OID changes. Now, the reason the things that I think it can be useful for at the moment, as I say, the first thing that I wanted to do is, while I was writing an internet draft, I wanted to validate the module that we were shipping. I didn't want to, have someone come back to us after we've published a new version of the draft and say, actually, no, hang on a second, there's some sort of fundamental invalidity in the ASM1 syntax. And it's used for that today and fairly successfully by the looks of it. So far, Russ hasn't come back to us and told us that one of our ASM modules don't compile. And similarly, it can be used for object prototyping. So during the development of a new object type, it's frequently useful to quickly be able to dump an example of that to send to someone to see if they can read it. And that's been used successfully a couple of times. For signed checklists, we've confirmed that the objects that get created by RPKI Mansa can be read by both RPKI client and another prototype implementation that Tom Harrison from APNIC built. And for the kind of the work in progress new version of the ASPA profile, I've confirmed that the objects that I create can be read by Krill. The other thing that it's useful for is recreating and finding bugs in RPs and CA implementations, and it's actually been used successfully for that a couple of times as well, which I'll come to. And what I would like it to be a little bit more usable for, but can still be used at the moment for this is to do integration testing and kind of software acceptance testing for RP and CA implementations. And of course, you know, the original itch I had to scratch, you know, ad hoc debugging of objects. Because an RP is by necessity fairly strict on what it ingests, it's quite difficult to extract useful information about what is wrong with an object from an RP, because it will kind of give up parsing as early as possible. And so having a tool that doesn't do any validation beyond the ASN1 syntax validation, and just dumps the contents to your standard out is potentially quite valuable. And so far we've found at least 2, you know, actual bugs in the real world using this. The first was a issue that affected, I think, multiple RPs, but I only know of the actual issue number in Fort, where it caused a crash. And this was caused by a CA's manifest that lists itself on its manifest, which causes a loop, and in this particular case, it resulted in a double free. The second one that we found was during that interop attempt that I mentioned a second ago, I was sent a demo object which had a common name attribute in the subject name, which was greater than the 64 characters that are actually allowed, and RPKIMANSA refused to eat it. And that points out a pretty important aspect of the approach here, which is that because the only validation that takes place is based on the ASN1 modules, none of the crypto stuff is checked. But what is checked quite exhaustively, because of PyCrate support for constraints, is all of the obscure constraints way down the dependency stack that nobody kind of thinks to check when they're writing this stuff by hand. And I didn't know before RPKIMANSA refused to eat that object, I didn't know that common name had a maximum length of 64 characters, but it turns out it does, and that's been confirmed in a couple of places now. And there's an issue open in RPKIRS to address that as well. I'd like to just quickly do a walkthrough for the benefit of anyone, you know, who might want to use this at some stage, of what a plugin for RPKIMANSA looks like to implement a new signed object in particular. So all of this repo I've got up on GitHub, and there'll be a link at the end of the presentation so that you can find it. Inside RPKIMANSA Poem, I've implemented just today a very, very simple RPKI object which allows you to sign a poem with an AS number. And this is implemented in RPKIMANSA with really just 3 files. The first is the ASN1 module itself, which is in RPKIMANSA Poem, and looks like this. Most of this is boilerplate. The actual object itself follows that syntax, a version that defaults to 0, an AS number, and a poem, which is a UTF-8 string of a maximum 200 characters in length, and a very, very small Python module which actually implements the object. We have to import a bunch of things, but what is on screen there is the whole implementation. And all it's doing is telling it which OID to use for the e-content type, what syntax to use for the e-content, what the file extension of the resultant object should be, and it needs properties for IP resources and AS resources. And the reason it needs that is because when you create an instance of this poem class underneath here, it will automatically generate an identity certificate with the necessary resources in it, and wrap the whole thing up in a valid CMS signed data structure. And so really the only kind of logic that you need to add is a mapping from a bunch of arguments, which will vary depending on the intended use of the object, to a simple Python dictionary, which kind of bears a direct resemblance to what's in the ASN1. And armed only with that, you can immediately generate it, because all of the heavy lifting is done in the ASN1 parser and encoding logic. There's then a plugin for the CLI tool, which is similarly simple. Again, there's a bit of boilerplate up at the top, and a default value for the poem, which I stole from the Ripe Who Is. And in order to implement a CLI extension, one just needs to subclass this Conjure plugin class, set up, define this init path to method, which sets up whatever additional command line arguments this plugin wants to receive, and then define this run method, which actually holds the logic for interacting with the library to create an object. And as you can see, this really is just garbage in and garbage out. It's two command line arguments, one corresponding to the AS number and the other to the poem, and those get passed straight through to the poem's object constructor. In order to use it, first we need to set up a virtual environment so as not to, start installing things globally. So, in fact, we don't even need to do that because I have one ready to go. So in this virtual environment, I've got a few things installed. The only dependency that the plugin has is RPKiMancer itself. All of the rest of these are pulled in by RPKiMancer. And it's not a long list of dependencies. Fortunately, PyCrate has no dependencies for the feature set that we need for this. It's all written in pure Python, which also makes it very slow. And so once we're set up and ready to go, we can issue RPKI and cant conjure, and you can use -v to turn up the debugging. But we won't for this because it's already a bit chatty. And you'll see it will always print some warnings. That is partly because of some slightly weird constructs that are used in the PKIX ASN1 modules that the PyCrate struggles to deal with sanely. And also because it complains about having to remove all of the default version numbers that are set to 0. So you'll see things like this repeated, but those are all fine, and that exited successfully, and it's created a directory here which contains a very, very simple directory structure that you would expect to find on a publication point or in the cache of your favorite RP. So it creates a tal for a trust anchor called ta.tal, and it creates a repo for everything under that trust anchor, the TA's root certificate, its publication point, which contains its CRL, its manifest, and a subordinate CA, and then that CA's publication point, which contains its CRL, its manifest, a rower, a Ghostbusters record, and this funny RSP object that we just created. So to look at, for example, a manifest, we can do RPKI and can't perceive target TA manifest, and that will dump the TA's manifest. This is in ASN1 value syntax. If we want it in JSON, for example, we can just do -J, and we'll get an equivalent thing back out. The JSON one doesn't decode the OIDs and stuff like that for you, which is inconvenient, but it's otherwise quite useful if you just want to extract a particular value using a tool like JQ or something like that. And then to have a look at our new object, we can just search for any RSP ones because we know there's only one of them. And this time we can have a look at the whole encapsulated content structure, the encapsulated content info value. And you can see we've got our e-content type. Our e-content type is a content type instance of type poem, and we've got our ASID, which just defaults to 65,000, and Nigel's poem, which is complaining about the state of RPSL and RIPE 181, which I thought was appropriate for this. One last thing to just point out, the way that the plugins are implemented, as I mentioned, uses setup tools for what are called entry points, which people, if anyone has written a console script in Python before, they'll be familiar with this. But essentially, this plugin simply declares, it uses rpkimanswer.asn1.modules to declare where to find its ASN1 module. It uses rpkimanswer.sig object to say where to find any signed object types that it implements, and similarly CLI.closure to declare any plugins that it supports. And so it's all runtime discoverable, and whatever you have installed in your environment is whatever the various tools will have available to them at runtime. So there's a few things that I still have left on my list to do, and that if anyone wants to contribute to, they're very welcome. I'd like to implement BGP-sec router certificates. I don't believe that it's going to be, I think it's going to be pretty trivial to do that. It's just a question of finding the time. At the moment, the directory structure that is generated by the CLI tool follows the directory structure that was used on disk by RPKI client from a couple of versions back. And what I would like to do is have a similar plugin architecture that allows you to output a directory structure according to what is expected by whatever RP you happen to be trying to read this stuff with. And that's in order to try and improve the integration testing experience a little bit. I'm in two minds whether this one's a good idea, but it should be fairly easily possible to generate the necessary XML files to synthesize a RRDP service locally. And I'd also like to implement something like the diff tool for signed objects, because looking at them in hex is not particularly helpful, and looking at them in text form is not particularly helpful. It would be quite nice to have a structure-aware diff tool for these, so that you can see, what changed between two instances of the same CA's manifest, for example. And then the other thing that I'd like to do is just make a template available to people who are implementing plugins so that it's easy to get up and running, because as I say, I've tried to minimize the amount of boilerplate, but it's certainly not boilerplate free. And as I mentioned, any help and suggestions and PRs and criticisms are welcome. Specifically, I think the areas where people can help that I'm not in a great position to do. For anyone that's implementing a CA or an RP, I'd love to have some feedback about what a convenient way of serving the data that this tool generates to a locally running RP looks like. Is it to spin up a kind of a dummy rsync server or RDP server on localhost? Is it to output files directly to some cache directory in a particular structure? Is it all of them? Do people have significantly different code paths that it matters whether something is retrieved from the network or just on disk when startup happens? That's feedback that I'd really like to have. And if the latter, it would be great to have in particular RP implementations own the plugins for their own directory layout, so that, for two reasons. Firstly, it's difficult to guess as a third party when or why something might change, and also it prevents that having to become part of the public API and make stability guarantees for it. If RP implementers are simply shipping a new version of the plugin for each new version of the RP, then nobody cares about the stability of that layout. And what does a good test harness for this look like more generally? Whether on the RP side or the RP Command side, what can be done to improve that integration testing experience? And in particular, one suggestion that I have is that none of the RPs, from what I've seen, have particularly useful or machine readable logs to work out why something's gone wrong. And I think that would be a helpful area to do some work on. For authors of internet drafts that define new signed objects, write a plugin. I've just shown a very, very simplified one, but the checklists and ASPA ones are maybe a dozen more lines of code than that dummy poem one that I just showed. And in the case of checklists, the plugin that implements that signed object lives in the same Git repo as the internet draft itself. And that has the advantage of being able to keep the version of the plugin in lockstep with the version of the draft. And it also has the benefit of being able to unit test the module that gets shipped in the draft using the plugin. And so that tight coupling works quite well. And if you have a look at that GitHub repo, you can find an example of how to set that kind of integration up. That's all I've had. Sorry, I've been waffling on for so long. But if anybody has any questions, then please ask, either now or via the issues or the mailing list or wherever else you can find me. Thanks.
Yep.
Hi, Joe Snyder. Ben, I have no comment. I just want to express my appreciation. I think this tool has been incredibly helpful, and it has helped discover numerous bugs. So thank you very much for putting in the time and effort to create this.
You're welcome.
As a separate comment, I think being able to look at the difference between manifests and RDP lists and or diff files and content for particular objects over time is certainly very useful. So it would be nice to see that.
So being able to do a diff between two kind of known versions of a given object should be fairly easy to implement. I don't expect that to be hard. The difficulty with making that kind of a temporal view is how hard it is to store snapshots of what the RPKR looks like over time. For a while, I had a GitHub repo with a bunch of automation that would run an RP periodically and just store the cache, and kept that for a while. But that thing, within a matter of a few months, grew so big that I started getting emails from GitHub telling me to turn it off. So I don't think that there is that's the missing piece of being able to do that easily and at the touch of a button. And I'm not sure that I have a good solution for that. And it's certainly not this tool.
Okay. Perhaps some thought process in the mailing list conversation about how to keep historical track of the RPKI, like we do with BGP and a couple of different places, would be useful.
So I've got some ideas as to how one might achieve that. The issue is you end up with a phenomenal amount of object duplication because of manifests and CRLs rolling over all the time.
Yep.
And I think that being able to track it on a more granular level than the file itself, down to the entries in the data structure, would eliminate that duplication. And probably give you a diff for free, actually, if you got that right. But that's a much bigger job than, you know, a small Python library like this is going to solve. It's a bigger question. That.
Yeah, sorry. What I meant was, oops. I guess Job says rpiviews.org, but what I was suggesting is something along the lines of like the route views and RIS storage mechanism for BGP data, some thing to hold over time the RPKI system as well. But also
Yeah,
Teams
so I
certainly
think
has some content.
I think that's what Job has built basically with RPKI views, which is a kind of a series, as I understand, it's a series of archives. But what it doesn't tell you a lot about is what the it tells you about the snapshots, doesn't tell you what happened in the middle, which is unfortunate, because usually it's the middle where something broke.
Job, I think we maybe one more question after this and we could skip over to Oliver.
If we want to track what happens in the middle, I think we need certificate transparency. That's perhaps a topic for the next IETF meeting.
Look forward to some slideware and discussion. I think, unless there's any other questions.
So if maybe I could just respond to T's comment in the chat quickly. I agree in general. I think hooking a test RP to this data is probably easiest to implement if you use one of the retrieval mechanisms like RRDP or rsync running locally. The problem is that because you need to embed the URLs in the actual objects themselves, you end up needing to kind of spoof your own machine's DNS in order to do it. Which can be done totally, but it just kind of feels like a little bit of an overreach, and it feels a bit clunky and prone to breakage on, you know, cloud CI systems, which is, but that's exactly the feedback that I was wanting to get. I suspect that being able to do both is probably going to end up being the right answer, but the question is how and who looks after that code.
Tees?
Yeah, Ben, I agree there. It's fiddly to set up and it's kind of an investment, but once you get it going, it's really nice. I agree that you probably need both.
Yep. Okay, thank you.
Thank you very much, Ben. That's cool. Oliver.
So let me see if I can share my screen or
Screen share starting, so you should be good to go.
okay. And I will take the screen. No. I have to move this one over. wrong screen. Let me check.
We did the rabbit hole move. Here we go.
Okay, so you see the main screen or the slide screen?
The slides. Looks good.
Good. Okay. So this year we decided to go a little different route than what we do in the past and participate in the hackathon. And in particular, what we were looking into is to develop tools and data sets for testing the route leak mitigation techniques. So the project was relatively small because we said, okay, we want to have a project that we can start on Monday and finish on Friday, in parallel to all the other work what we had to do. And so what we did was, as you know, we have the NIST BGP SRX software suite, what we back then developed first for the origin validation, and then later on also for the BGPsec path validation. And now where we are talking about the ASPA verification, we also added this implementation to the software suite. We implemented the ASPA verification 8, including some algorithm corrections that Sriram presented in IETF110. We also implemented the 8210-BIS3, where we basically bring all the ASPF information down to the router, or in our case, to our validation engine. So what we wanted to do is we needed some scripts that allow us to generate simply and easy large-scale test data to what can be used for interoperability tests, and also later on maybe for some research kind of parts. So if we look at the data flow, so basically data flow, take it with a grain of salt. So you register your ASPA object, and then the validation cache gets all this stuff, validates it, and shoots it over to the routers. And that is the area of our interest. So we have the validation cache test harness that does not do the 509 validation and all this kind of stuff. It basically takes data what we assume as already validated and sends it over to the router, because our part was more interesting always on this side, so that was like a test harness what we use. The validation cache has a fairly nice CLI where you can basically even script experimentations with timing and what have you. So we wanted to create input data for this cache test harness, and input data on the right side of here, where we get route views, update data, and then have all this stuff validated. So our first task was basically to create the ASPA dataset, and the cache test harness take them pretty much in an ASCII version of the 8210-BIS3 PDU. We used as input data the CADA data. That's a very nice data set where they go out and look into the internet topologies and try to infer peering relationships. And then we create our test input, looks basically at an ASPA with this particular AFI, my customer AS, and then the whole bunch of provider ASs behind that. And then, of course, also create sample BGP updates from route views 3. That was the collector what we used. So what did we do? We created a script that takes the CADA data and formats a little bit in a different way so that we can work with that. And we created around 72,000 plus ASPA PDUs. And they contain around 100, a little less than 150,000 customer-provider relations. last Friday when we presented that to the hackathon, I had a little calculation error. I said we did around 180,000. I over the weekend I went one more time over the stuff, and it's more like 150, but you know, give or take. The part is that you don't always want to test with this huge set of data. You want to be able to down select that. So we created tools where we can down select the ASPA data depending on the updates, what we found or what we will play into the router. And then we created an output what we believe is easy to be used if you want to make comparison between different implementations. They should basically have the same outcome. So and I'll show that later on. So we created a couple of data sets, one with 100 updates, 500 updates, 800, 1,000, 10,000, 20,000. You can create whatever you want, and the tools go out through the raw data and generate you a nice set of the ASPA input and the BGP traffic that fits to that. So the first thing what we did was we looked at, okay, how do we do the peering? So we, as I said before, we took the MRT data from route view 3, and we selected the table data, not the update stream, and then we said, okay, for our BGP IO traffic generator, we have a slight different format than the data. So what we did is, you see here on the right is basically printout. We have the prefix, then our B4 basically means generate only BGP4 updates, because remember, this traffic generator originally was built to create BGPsec updates, and we are not interested in BGPsec right now. And in the past, to create BGP4 updates, we just didn't give any keys and had as fallback BGP4. But this is just resource waste, so we added these B4 where I can say, okay, don't even deal with BGPsec. So it creates a BGP4 update with this route. We removed, and what we did was we basically created a file for each peer that sent their data to this particular collector. But then we also removed the peer out of the data stream, because, so this one here, for example, is a data file of 701. So normally you saw 701 all the time in front of it, but we created the file 701.txt, and then these are the updates, and then BGPsec IO will take on the role of 701 and play these updates, and of course it puts its own AS in there. So that's basically what we did on this side. And then on the other side, the CADA data. So what we did, we said, okay, let's go through the BGP update, and we only generated ASPA data, CADA data, or no, sorry, we only generated the ASPA input data containing custom ASs, what we saw in the BGP traffic. Of course, you could say, you know what, I don't care about this. I shoot all 72,000 ASPA data to the router, and everything works fine. That's perfectly good and yes. But sometimes you don't want to have everything sent directly. You wanna reduce a little bit the data set what you work with. It might be for debugging purpose or other things. And then we created the test traffic. So as I said before, you saw pretty much this file, but it had real prefixes. And in ASPA, we are not really interested in the prefix. We are more interested in the path. So what we did was we went through the, if I want to say I want to have 100,000, or I want to have 1,000 or 10,000 routes, we are interested in 10,000 unique routes. So we prune the BGP traffic data one more time. We throw away all the prefixes. And then we said, okay, we only take the unique AS path, And then eventually, because we need prefixes, we just we generate synthetic prefixes. They start by 001/0/24, and then just run down with a counter, and it could go up to 255, 255, 255. Why are we doing that? Because we want to make sure that we get every path in. Because even if we don't do that, we would, for example, keep the original prefixes what we have in there, and we would say, okay, select the first AS path, of this lookalike. The chance could be that you have duplicates if you don't take the table dump, but if you took the BGP live stream. And because we don't want to rely on the that you use a table dump, we said, okay, let's deal with that. That's the easier way. It's crude, I know, but it does the job. And then we again, this whole thing is done automatic. So I always like plug and play. I always like you have 1 or 2 scripts and it does everything in the background for you, because you don't want to waste your time in generating the data. You want to waste your time, or you want to spend your time in testing your software or creating data for analysis. So we have a tool that is called generate data, and then I give my prefix, in this case 701, and I say, give me the first 100 unique AS path, and then it goes in our, it's a file-based database thing, or it's not really database, it's basically a directory where you have a file that's called 701.txt, and then it generates out of this all the things, and it creates the input file. We call it with the extension bio, that is for the BGP IO, that contains the updates. We have one file that contains all the unique ASNs. We could have deleted it again, but we kept it in there. Just sometimes you want to know what are the ASs, what you use. You don't want to have the unique number of that. And then we created out of the big 72,000 ASPA data, we created a downsized cache file, and the files are generated like the AS number what I used, the number of updates, and then it tells me what it is. So it's fairly straightforward. Then we started our and then from the scripts, there are 2 ways how you can start the experiment. You can start it from a console where you just remote log in, or you can start it preferably from a this is all on Linux, from a Windows system. If you use the terminal only, then what it basically does, it just starts all the modules, the cache test harness, the SRX server for the validation, the Quagga router, the BGP IO, and it runs everything in the background. It redirects all the output to standard IO and arrow into log files. And it works fine, but the problem is sometimes you run into issues, and then it's really a pain to, or you want to manipulate a little bit. Our cache test harness has a CLI where you can add and remove data on the fly, and you cannot do that when you run it there. So therefore, we have a GNOME terminal that is a preferred one. So you start it, it moves, or it starts every module in its own tab, and you can easily then switch between one tool and the other one. So that looks pretty much like this. So I start the stuff, and here I have my start service. I say use my terminal. The -W basically means in case one of these crashes, normally the tab would immediately disappear. The -W says we ask for a key input before the Windows closes, so that you have a chance to look into this window and see what happened. That is especially important when it comes to the traffic generator, because sometimes when Quagga SRX is not ready yet, and we start this too early, it tries a couple of times to connect, but if something goes wrong with the connection, this one just stops, and then you want to know what's going on, and you might have to do something in timing or query for open ports or what have you. And there it's nice to see, okay, did it actually run or did it crash if something is not coming out the way you want? Again, so you start that, and then it automatically configures the router. So that's a nice thing. We have templates. If I say I want to run it with 701, then it configures BGP-SecIO to act as 701. It configures Quagga that 701 is a peer, and so forth. It starts everything. We have some timing in between, and at the very end, it asks you if you press R for the results. Then what it does, it makes it's like a telnet hack where we go into Quagga and we make a show IP BGP, and then with some regex we modify the output so that this one is basically the output, the result output, what we want to have, the validation state and the AS path. And you can also start the service by just start service and then a parameter. I think it's called -view table or minus view table, and then it does this one for you as well. You run a little bit into problems there that when the data set is too big, that we lost the connectivity between Quagga and the telnet session. We did some timing there, but there's something else going on. So I don't know if this one is the best way of doing it, but for smaller data sets, it is very nice. Maybe it was also just my system that cracked up there a little bit. So we have to look into this one going forward. But for the time being, that's a very good way of doing that. So what did we do? We basically used the large-scale ISP in the data from CADA from October 1st, 2020. We use the October 1st, 2020 data because CADA right now is rewriting all the algorithms, and that's the latest data set they provide. We created a subset of unique routes, and with the CADA data, we performed the ASPA validation, and we set the IoT as a private AS. I think it's a 65,000 what we use, and then we run it against it. That was the results. But again, you have to take these results with a grain of salt, because one thing, for example, we run it where the ISP is a provider, and that's fine. And then where the ISP is a customer, but I would assume that if the ISP is a customer, it would send me different data than if it's a provider. So again, you can choose other ISPs, but we just wanted to show though. So even though that is that I would be careful with analyzing this really deep right now. You see if it's a provider, you have most of it is valid and just a small of invalid. So it just gives you already some ideas. And then this was a relatively small data set. Depending what data it would be there nicer to have or to play them the whole. I think the 8,000 prefixes ended up to be 100,000 unique routes or so, but don't take my word for that. It might be that it's even a little bit more. It makes more sense to then really look into what kind of data you want to put if you want to make serious research on that. And again, it was this data we generated in the middle of the night before the hackathon presentation. So I was happy to have at least something. So the code itself, we will put on GitHub. We don't have it on GitHub right now. I don't know right now if we will put it on the hackathon GitHub part or if we make it part of the NIST BGP SRX GitHub. But doesn't matter at this point because I still want to clean up a little bit. It's a little crude, so I want to have it in a way that if you're interested in looking into that you actually don't have to fight for 2-3 hours to figure out how the stuff works, but that you have all the information needed that you can do it relatively quickly. And then we will send an email out to the list or even have it on our, at least on our NIST BGP SRX GitHub page. We will have a reference to where the data can be found. Or if you want to have it in the state as it is right now, just drop me an email and I just wrap it up and send it to you. So that is this. Now, why did we do this? We said it would be nice again to maybe start using hackathon for these simple small scale projects and maybe finding others who are also interested in doing that and tackling just a simple problem and trying to get this done within the 7 days or the 5 days of the hackathon and bring it out. So one thing is what I'm personally very interested in is taking really a larger scale set and then playing with gradual deployment. So for example, our cache test times, what we can do, we can say if I have, let's say, 1,000 ASPA objects, I can say, play the first 100, then wait 5 minutes, play or wait until I press a key, and then press the next 100, and so forth. And with this one, then you could basically run and always see what is the validation output and see how would it look like if we have gradual deployment. That is one thing. And of course, if this one is automated, it's even better, because I always prefer as little user input as possible necessary, but I also want to have the chance to give my user input if I want to. So then the other thing is currently we made it with one peering session. Maybe extending the scripts, and it's all in shell scripts, extending them to allow having multiple peering sessions. If you want to start looking into performance testing of the router when you have multiple peers. And testing, scaling. We run in some issues in our implementation with scaling. That's why we couldn't run the full scale. We found one segmentation fault. Unfortunately, what we will now start looking into, and hopefully we have it fixed within the next week or two, and then we maybe can look into really the full table. You know, we were loading the 72,000 ASPA objects into our cache test harness. That worked, was very quick, was very nice. We fed them into the SRX server. That went very nice as well. We just have to see that we manage our memory correctly in every little thing. It might also be that my VMs just run out of memory. I don't know. I didn't look into that yet. At one point, I said, you know what, let's do this after IETF where we have more time and can really carefully look into this stuff. Then maybe it would be really nice to test this also with other implementations. So you can take our shell scripts, and instead of starting the SRX server and Quagga SRX, you can start your own implementation and run it against that. And it would be maybe nice to have other reference implementation implementers to partake maybe next hackathon to work a little bit on that. Another interesting part is looking at the other side of it. So taking the CADA data and not only generating the data for the PDUs, for the 8210 PDUs, but creating the input data for the validation caches, so that you can take your validation cache and test it, and then you don't need our test harness, but we could run it against the real validator. That would be something really nice too. I don't know if I can do it right now because I didn't work enough on this side of the project, but maybe others can join. That would be something really cool, and I would really look forward to doing stuff like that. So that's it for now. So if you have any questions, speak up now, or down there we have, or send me an email. If you have questions in general, what we do in this field, we have like a group email for us, is itrgcontact@list.gov, and just send it there, and then we will find the proper person who can answer your question. And with that, I think I'm done. Thank you.
I think there's 2 questions for you, Oliver.
Okay.
I think Rudiger maybe was first, and then Alexander.
Yes.
Oops.
Go ahead.
So, am I being heard?
Yes.
Yes.
Okay. Well, nice project. One stupid, simple syntax question. The syntax that you give for the ASPA test data ends in an asterisk. No, ends in a plus sign, and I guess it should be a plus.
No, it is a plus. Did I put an asterisk? And that might be a function of create your slides in the middle of the night, I would say. No, there is a plus. the provider.
Yeah, well, okay. Yeah, but kind of that precludes empty AS provider sets, which I hope still are in ASPA.
Oh, if they are in there, then maybe again. So let me check if it has to be a star. I hope normally our implementation should do that. I thought it was always a plus. Yeah, then this will be changed. Thank you so much.
Thank you.
Yep.
Under.
So first of all, thank you for the report. It's good to see more testing evaluation around SPA. But I have two questions. The first one is about your source of the data. Since you were using CADA, as far as I understand, and as far as I remember, CADA peering relations is based on some kind of expert set of tier 1 providers. And the thing is that these tier 1 providers are not in the customer to provider set. So you should have explicitly create what is called now SPA 0 or empty SPA. Have you done it? Because I'm very surprised with the number of unknowns that are in your.
Again, that's why I say take the data with a grain of salt. We did not really. The only thing what we did for CADA data, we looked basically into the peering what they gave. We didn't really spend time into really adding other things or analyzing the data correctly, because for us the main issue was for the testing that we wanted to go scale test and having some data set that would make some kind of sense rather than just randomly generating something. And again, this data currently is not meant to go out and start making real in-deep analysis. Why is it now like that or like those? You also have to see what kind of AS you choose. You know, I mean, here right now we chose 701, but you know, I mean, if the peer is your customer, you would expect a slight different kind of update stream what you receive than if it is your provider. So again, the main part is this: even though if the data what is in its greatness or not that greatness, the main part is that if I have two implementations that take this data as input, the output should be the same. So with this, you can at least assure that the validation itself, the validation algorithm in the implementation is deterministic.
Okay, I understand, but I will just highlight my point that you should check how you are processing data from CADA, because once again, what is called tier 1 providers will not be in this data because they are in the source of the algorithm, but the data shows only autonomous systems that do have providers. And the second comment is about the CADA data itself, because everybody knows that it is kind of noisy. You may have both kinds of false positives. You may have the autonomous systems that are named to be providers when they are not. And the more important one, when there are missing providers. And such a situation may turn into the invalid outcome. My suggestion is to not using the big set of autonomous system relations, but to use top-bottom approach to start with simple SPA records for tier 1 providers. That's what we did in our detection system, and it just works. There is very rare noise in this kind of system, and combining this kind of approach with route use, what you just did, I think it can be very interesting research.
Yeah.
But anyway,
mean,
thank you for your vote.
I mean, agreed. You know, it's always the data, but for us, the main part is we wanted to have a very quick way to generate large scale data sets, and we have handcrafted ASPA experimentation. What comes with the software suite? What we have in there? We have a complete experimentation framework, and that's all fine. But I mean, Kata was what is right now around. And I know it's not the perfect set, but it always depends for what you want to do. If you have other sources, though, that we can use that maybe give more or a better data set, even for looking into working with, I'm more than willing to use them as well. Again, I think it's better than just having a random number generator to generate ASPath or customer peer relationships. And yeah. But thanks.
Sriram and Doug are in queue.
Yeah. So this is Sriram. Answering some of Alexander's questions, one of them is like small data testing with some small data. We do have, Oliver didn't mention it, I think, but we do have like small data also, which is synthetic with experimental AS numbers. So we can also make that available, in which case you can just do a quick test and see an output that is only 12 ASPA or 12 updates or something like that with few ASPAs, and you can do a quick simple test. So that's available, and I think Oliver can make is planning to make.
No, this one is available.
That is already available, right?
Yeah, that's part of when you go to the NIST GitHub page.
Oh yeah.
And it's part of the experimentation set. Yes.
Right. Okay. So another observation that Alexander made, and he does have a sharp eye on one of the results slides, which are, of course, like Oliver said, needs to be taken with a grain of salt. But Alexander did observe very correctly that the number of unknowns is large, and that indeed happened also for the reason that Alexander speculated or guessed. And that is when you have tier 1 ASS, we realized it over the weekend after the hackathon was completed. We realized that for tier 1 ASS or any ASS that don't have providers, we should have an ASPA, AS0 ASPA. So that's going to be fixed. It's very simple to fix it. We identify the tier 1 or ASS that don't have providers, and we would add ASPAs that have ASPA 0 in them, and that would fix that problem. And Alexander, you will see that once we do that, the unknowns will not be so many. They will in fact become invalid because something like the way the experiment is being done is a little bit unnatural. The 701 AS, which is a tier 1, in the second set of experiments, the IUT considers 701 as a customer, which is unusual. And so once we fix this, if it's considered as a customer, many of the routes will become actually invalid. And so there will be a shift from unknown to invalid once we fix the ASPAs to include the tier 1 ASPAs with AS0 in them. And the third point, picking up on Rudiger's comment, there is no such thing as, Alexander, correct me if I'm wrong, but from the draft, there is no such thing as empty ASPA. There is AS0 ASPA, which you would create for tier 1s or ASS that don't have providers. But there's no such thing as empty ASPA, right?
About your last point, yes, you are correct. At the moment, the draft says that the empty should be represented with ASP 0, likewise it is done with rows. In the mailing list, there is still ongoing discussion on the subject. We'll see how it ends up, but the syntax is correct in the slides. So, and thank you for giving comment for my comment.
Okay. Thank you. Thank you so much.
Yeah, maybe one thing what I also want to say, the syntax basically is based on the draft ACE 8210-3, and the PDU that gets sent over to the router, I think, has a plus in there. But again, I will verify that, and if I'm mistaken, then we will of course make the modification. Or maybe the ACE. Then we will deal with this. Yes.
Okay. Any more questions? There was some chat stuff about why and wherefore the data came from, which seemed to clarify some of Alexander's questions as well. I think, lacking any other people showing up at the mic line, I think we're at the end of today's agenda. And I would thank Oliver and Ben both for some actually pretty cool talks. And I think that's it. I think we can all go off to do what other things we're supposed to do. Thanks a bunch.